Good morning, class. So before we begin today, I need to ask you all a few questions. How many of you have been in a vehicle? Excellent. How many of you have been swimming? Very good. And how many of you have hit a baseball, thrown any type of object? Great. So all of you have real-life experience with what we're going to talk about today, and that's Newton's 3 laws of motion. So Newton discovered that there were 3 laws that affect all objects. And his first law states that an object at rest will remain at rest, and an object in motion will remain in motion until it's acted upon by an outside force. So when we're in that vehicle, we've all noticed the brakes are hit, our body continues to move forward until it's caught by the seatbelt, we stop with our hand on the dashboard. Something has to stop us because our body is moving at the same speed as the car. But when the car stops, it doesn't stop our body. Our body continues to move. And an object at rest, I have a phone. If I keep that phone sitting on the table, it will remain there indefinitely until I decide I'm going to pick it up, I scoot it. Something has to happen for it to move. So an outside force, such as my hand, has to stop it. Newton's second law, when a force acts upon an object, it causes that object to accelerate. So when we're playing baseball, you swing the bat and you hit the ball. The swing of the bat is the force. The ball is an object with mass, and it accelerates. It moves quickly. Now, if we hit the ball hard, trying to hit a home run, it's obviously going to accelerate more. But if we try to bunt it, we're not hitting it very hard, so it's not going to accelerate that much, and the ball's not going to go very far. So we can look at that in terms of, we have a paper wad that obviously doesn't weigh very much, and we have a phone. Clearly it weighs more than the paper wad. If I apply the same force to both objects, such as the flick of my finger, the paper wad moves pretty fast. But if I do the same thing to my phone doesn't go very far because the phone weighs more. The mass influences that. If I wanted this phone to go as far as the paper wad, or to accelerate as much as the paper wad, I would have to apply more force. Okay, Newton's third law. For every action, there is an equal and opposite reaction. This is a great thing with swimming, okay? You see these swimmers, we put our arms into the water and we pull back so that our body can continue to move forward. The faster we move our arms through the water, or the harder we move them through the water, the quicker forward we go. If I just wanted to casually swim, I'm not going to move it very hard, and my body's not going to go very fast forward. So if you look at rubber bands, if I pull the rubber band back slightly, it will go a pretty good distance. But if I decide I want to pull the rubber band back even farther, it goes quickly and it moves farther because it's equal yet opposite. So the pull of the rubber band is the action, and the distance it goes is the reaction. Alright, so now let's see if we can apply some of these to other situations that we can encounter every day. Alright, a soccer ball accelerates more than a bowling ball when kicked with the same force. Which law is that? Show of hands for first law? Second? Third? Excellent, it's the second law of motion. The force, when we apply force to an object, it accelerates, but the mass is also important there. The larger the mass, the less it will accelerate from the force. A bird flaps its wings downward in order to fly upward. So it's moving its wings down so that its body can go up. First law? Second? Third? Excellent. It's the third law of motion. Every action has an equal yet opposite reaction. So when the bird moves its wings downward, its body is going to move upward. And the faster it moves down, the faster it's going to move up. Equal yet opposite. Finally, we have a picture. All of us have pictures. And it's going to hang on the wall. And it's going to continue to hang there. Which law? First law? Second? Third? Excellent. The first law, an object at rest will stay at rest, and an object in motion will stay in motion until it's acted upon. That picture will continue to hang on your wall until you move it, until something hits it, Something has to happen to it to make it stop being at rest. All right, great job today, guys. You have successfully learned one of the most important concepts of physics. Great job.